Hello, this is Itsu. Okay, short video hopefully about this stalker modules I'm trying to build. I started out with this big diagram which contains kind of two modules. I call them module 1 and module 2. The first module is the TL494 and the delay chip, the 4093, which goes to the push-pull MOSFET drivers and the yoke. And that's what I call the first module, which is the left part of these two modules. These are two separate modules. I hooked them up together, but so this is the TL494 together with the first delay TC4093 chip. And the second module is the what I call the short pulse cache driver module with the two 4093s and the two pot meters. And this is here this second module. We have the two 4093 chips and the two pots. And I was expecting that at this point the output of that module, we could directly drive this this third module, which is the cache driver, transistor driver with the three FETs. But I was thinking that this would also generate the little pulses I see in one of Starker's video, but when I built it there was no pulses. And another thing is that the output of this one is a positive going signal, while at this diagram we see to expect a or the other one is a negative output signal, which I will show you later. And this diagram expects a positive pulse, so there is some mismatch here. So I was looking for another module which was on the forum, and it turned out to be this one, the module 4 I call it, which basically is what Nick also showed in a quick and dirty drawing. An extra IR 2113 followed by a 4093 again, producing from a single downwards pulse some positive pulses. So I built this one as well this afternoon, and it turned out to be this module. Here are the IR, what is it, 2113 somewhere, and this is the 4093 chip with the two pots. And this one is now what I now have working. I have the yellow probe on the output of the TL494, of one of the outputs of the TL494, and I have the blue probe on the output of this signal, and you can see it is a downwards pulse and not the upwards pulse we are expecting here. And finally what is it, the green probe. Purple probe is not connected. The green probe is the output of this multiple pulse thing, which needs a MOSFET driver here behind driving a MOSFET and not a transistor. That's, I think, what's going to be. So these are the signals we have. Yellow is one of the TL494 outputs. I've put it at a 33% duty cycle like Starker showed. Blue is the output signal of the double module 2, the two 4093s. and you can see it's a negative going pulse, and green is then the output of this new module 4, which has some pulses now. And with the pots you can manipulate the amount of pulses and the pulse width and so forth. Let me show you. I can turn one of the pots. I'm not sure which one is doing what, but now we go from 3 pulses to 3 to 2 pulses, and if I continue we go to 1, I guess, or if it's out of reach of the pulse. There's another pot there, not sure what that's doing. I think it's doing something with the pulse width of this small pulses. Yeah, it's going smaller. So there are some things we can do with this new module 4, but I think it's just to drive a MOSFET driver, TC4420 or whatever, and to then drive a MOSFET and not a transistor. That's I think the purpose of the MOSFET drivers. And we can of course move this blue pulse across this and set the timing later on. So this part is working, but this is not for the transistor as I understand it, but it's for a MOSFET driver. Okay, and the third module which I built here, this is with the 3 FETs. This is basically this signal, and this one needs not a downward pulse, but it needs an upward pulse. So we can change the output from module 2 to one of the other points here. So instead of taking it from point 10 of this 4093, we can take it from what is it, point 13 or 12. Then we have an inverted signal. So that's not a big problem, but it needs to be taken into account that you need a different input pulse. And then I built it and I made it, but I'm not sure what kind of output signal to expect. At this point here we can see what the signal of the base of the transistor will be, which is this point. I do not have connected the base of the transistor. I don't think it's necessary. I just want to see what kind of signal I got here, and it's not really what I expect, but anyway, I will connect this one now and show you the signals I get there, and perhaps anyone can tell me if that's correct or that's what we need or not. Okay, hang on. Okay, I'm back. I have removed the MOSFET driver module and I replace it with the module 3, which is the 3 FET driver. These are modules 1 and 2 again, still at the same point. I have changed the output, not from the downwards, but one of the outputs earlier to get the inverted signal. This signal which we want, the upgoing signal. And you can see here again, yellow is still the TL494 output, blue is still the output of the module 2, the original place, the downward signal, and green is the signal, one of the outputs earlier on the diagram, so point 11 instead of point 10. So we have there a positive going signal like it is required here on this diagram. And purple, you can see the output of well, it's the base of the transistor cache driver. So I'm measuring here without having the transistor installed. This is the signal I measure here at this point. And well, yeah, that's the question. Is this what it needs to be? I mean, it's a 5 volt something pulse. They are at 5 volts per division. And will this be enough to drive this transistor? And it's a single pulse, so we only get a single Kesher resonance pulse on top of the sine wave of the push-pull, I guess. But yeah, the question is if this is what we are looking for. Is this the signal needed or wanted out of these 3 FETs? I'm not sure, and perhaps the only thing is to try to activate a transistor and a Kesher and see what's going to happen. But perhaps some guys of you out there can tell me what kind of signal they're supposed to be before blowing any transistors. Okay, thank you for watching.